Hello everyone, my name is Jack. Today I want to talk about global sea turtle conservation success. Introduction. The population of mammal, bird, amphibian, and fish is decreasing, and it prompts people to concern that planet is experiencing a sixth mass extinction. And there are some effects is connect with this decline. The activity of humans, such as fishing, hunting, and poaching, habitat loss, disease, introduction of invasive species, and climate change. The solution of government. In the countryside, they sign intergovernmental agreement like CITES. In local side, they set up of the marine and terrestrial protect area. But this program is helpless for reverse of migratory species. 6 of 7 sea turtles have been listed by IUCN as vulnerable, endangered, or critically endangered. This is the species our use in research is there and there. Our purpose is we collect all the time series of sea turtle nest number and calculate annual growth rate and analyze the different trends in these 10 time series. We hope the result can help people know the status of sea turtles. Material and method. We collect all the time series of sea turtle nest number from scientific journal, newsletter, internet resource, and we select a median of 6-year data to detect trends. Trends in geographical distinct population segment. RNUS is a unit, and we use RNUS to group distinct population in different places and analyze the trends of nesting abundance in each RNUS. We see this picture. Yellow circle is nest, and blue area is 1 RNUS, and there is totally 3 RNUS. We use annual growth rate for statistical analysis, and NL is mean abundance in the last year of the same time series, and NF is mean abundance in the first 3 years of time series. Result. We use this function number of the significant trends event divide the number of event, this point, black point, and get the proportion of significant trends, and we get this figure. X-axis is length of time series, and y-axis is proportion of significant change. And we can know 130 have significant change from data, in totally 299. And we see the line, we can find that the longer length of time series on event, the more significant change event will happen. And there is no significant change in abundance of 169 from less slice. So we use this figure to explain it. We can see that x-axis is last year of data for published time series, and y-axis is number of time series. The red area is data do not extend beyond 2009, and totally 118 cases. We can know that from this figure that the number of no significant change has connect with data extent. And we see the figure C. X-axis is the number of start time series, and y-axis is annual growth rate. We see the figure, we can know the low number of start of time series, but the annual grade is high. When the number is increased, the annual grade rate was decreased. So we can get this. We can get when the initial nesting number increase, grade rate will decrease. And we see the line is the average growth rate. We can see that in most of event is positive. So we can know that, we can show that success of sea turtle reverse. We can also know that airlift effect not happen in sea turtle from this figure. And this figure tell that each RNUS, the upward trend of or downward trend of their mean grade rate in nesting number. Green circle is the upward trend, and the downward trend is red circle. And this is the turtle. Discussion. We will discussion that sea turtle and alley effect. Alley effect is a situation that when population density or population size increase, the growth rate will increase. And when population number is extremely high or low, the number of the species will not increase. Like this picture, their population is very low, their growth rate is down, and high also. And we concentrate with these two pictures. We can get that with from our result that that the initial nesting number of sea turtle is high, the annual growth rate is high. So we can get that any effect is not happen in sea turtle. And why any effect do not happen in sea turtle? Because both male and female sea turtle often return the place near their nesting site. That is, the chance of male and female meet will increase. So even their population is extremely low, they have high fertility rate. Conclusion, we find both encouraging population change at RNUS level and some worrying population decline. We find low abundance have the potential to recover. These findings highlight the value of local conservation work. And we find the most of the reverse succeed, and the sea turtle do not have any effect. Thank you for your attention.
Can you explain why the population number is high, or extremely high or low, and the number of these species will not increase? Why?
Why?
Repeat the question.
She want to know why population number is extremely high or low. The number of the species will not increase because some source for species he need will when extremely high, their source will not enough to support the species survive.
Not source, resource.
Resource. And when number of low number, when they low number, the species meet, chance of the species meet will decrease. So their fertility rate will decrease.
I want to know how to get this equation.
I don't know because the paper only show the increase the formula, but it didn't say they where they get the formula.
Can you take some short example about the alley effect? Short example. Other animals. Yeah.
Alley effect.
Repeat his question.
He want show some alley effect example. Because the paper doesn't mention it, so I don't know other species will happen in any effect.
NL and NF, what is abundance for what?
for next T number.
Can you say the purpose of this study again?
Repeat.
Purpose of
Purpose.
purpose. Oh, he want to know purpose of this study. We want to make the figure to let people know sea turtle status. Let people to concern the sea turtle.
You say your purpose is made this map.
Huh?
You say your purpose is made this map, but your conclusion is not this.
This is their population trait, and show in the this page.
And what is the relationship between this and your effects? Page any effect. What relationship with this map and any effect?
Any effect is a part of some sea turtle. Some place of sea turtle. And this is the whole any effect we happen with some decrease some some praise, but but it
Why did the upper trend happen more in the Atlantic and the downward trend more in the Pacific?
Can you say again?
The green point that happen more in the Atlantic and the red is happen more in the Pacific. Why?
The paper mentioned it, but I forget.
Okay, my turn. So I think the clarity of this presentation can be further improved. So first of all, you spend some time talk about these RMUS, which I know it seems to be important for this talk. However, I actually do not understand what this. Even if after you put a cartoon, I still have no idea. And you say one RMU and you have a plural S, so it's a little bit confusing to me, you know. Usually it's one RMU or 3 RMUS, not one RMUS. I don't know if you understand what I meant. Anyway, this cartoon is not clear to me. So I hope that next time you figure out a better way to, I think you understand what RMUS. So I hope next time you can improve your clarification. That's the first thing. And then later you talk about this equation. This equation is actually quite simple. And however, it would be easier if you draw a picture showing a time series. A time series usually means there's a data that collected over years, right? And you can draw a time series yourself. And then you say, okay, this is the abundance of the turtle nest or something, or turtles. And we take the first 3 years, the data of the first 3 years as NL, and the final last 3 years, or the other way around, or the last 3 years as the NL and NF. And then I think what was missing here is apparently the authors used this equation to define, because the confusing thing about time series is you cannot always say for sure if the line is increasing Of course, when I draw a line like this, you know it's increasing. And a line like this, you know it's increasing over time. But the most case is like up and down. So you don't know if it's increasing or decreasing. So you need a criteria to say, yes, it's increasing, or yes, it's decreasing. Because here in your data, you always say, significant trends. This is keywords. How do you define what a trend is significant? When you say significant, you mean significantly increasing or decreasing. So you need to tell us how you define that. And then here, and here you said this concluding remark is unclear to me. I don't know what you want to say with this remark. So I think next time you should consider another way to clarify this point. What is no significant trends have connect with data's extent? I don't know what this is about. All right, and I think alley effect is well presented. However, again, when you use a figure like this, you have to tell us what's the x-axis, what is the y-axis. And then it's great that you compare the figure with your own data. So we know, okay, we need to see something like this to know its alley effect. Okay. All right, so I think the conclusion remark is good, but I think at the end, I think you might be able to add some numbers. I think in the abstract there are numbers to tell us what are the proportion that's they found increasing. Yeah, and I think again, I think this one is vague. I don't know what this sentence was talking about. So I think you need to improve your clarity. Okay, thank you, Jack.